Alright, so now we're going to talk about dilutions. So I think probably everyone in this class has done a dilution at some time or another, and it's just watering something down. That would be kind of the common English terminology for that. If you have a drink and it's too strong, you water it down. You're diluting it. You're making the solution weaker. Um, so you've got concentrated orange juice. If you let it thaw, it becomes a liquid. Maybe that makes it easier to understand. But also, mix it up. You add water to it. You're diluting it. You're making it the concentration it's supposed to be. So I think probably everyone's done a dilution, but we'll give a very technical definition. Make sure we're all on the same page. But do understand that this is a case where the technical terminology and everyday language dovetail very nicely. How we use dilute in everyday language works perfectly with what we're going to do here. So if you're like, I know that word, congratulations, you do know that word, and I'm not going to switch on you. This isn't like accuracy and precision aren't the same thing. Mass and weight aren't the same thing. Like dilution is dilution. So, and they used to say dilution is the solution to pollution. That's a fact. So, if you were setting up like a chemical factory, like you made, I don't know what the first chemical factories were. Oh, they were clothing dye. I mean, clothing dye in the 1800s. That's literally where all of, everything started. Then they started making pharmaceuticals. That was the second thing. That was what chemical plants did. But if you set up, one of these 1800s dye factories, you needed a couple things. First one, you gotta have a railroad. You gotta ship in your raw materials, you process them, you ship out your products. Okay, cool. The second thing you needed was a river or a lake, some body of water, so that you could dump your waste into. That was it. It was, oh, that's a big body of water. It'll be fine. And so the Cuyahoga Lake in Cleveland, Ohio has caught on fire, I don't know, it was like 5 or 6 times. But the last time in the 70s, maybe it's happened since then, but one time in the 70s, it really shook everyone awake, and they made the EPA and made regulations about dumping into, waterways and things like that. Because it turned out if you didn't have regulations, people just dump stuff in waterways to the point where you don't usually expect a river to catch on fire. Like, you don't expect there to be a no smoking sign by our river, because you might die because it burns you to death. But, very easy fish fry. That was the flip side. Catch that thing on fire, all the fried fish you could eat. And I'm sure they were delicious. Tasted like Red 40 or whatever. Alright, so dilutions. Now, what's the technical definition? So, a dilution occurs when more solvent, and oftentimes in our everyday life, solvent is water. That's why we call it watering something down, but more solvent. So whatever the solvent is in your solution, you add more to it, is added to a prepared solution. And so what this does is a couple things. So concentration always goes down, and volume always goes up. If this doesn't happen, you didn't do a dilution. I don't know what you did, but it wasn't a dilution. Because you're going to add solvent, so your concentration, the amount of solute that you have, is going to be spread out over more solution because the volume went up because we added stuff in. We added more, water or whatever, and so maybe we doubled the volume. But we didn't double the amount of stuff dissolved, so it gets, half is spread out, and you get half the concentration. And I'm going to just dive right in, and I'm just going to give you the dilution equation right off the bat. I used to kind of like work my way up to it, but in my later years here, I've realized it's much easier to just show you the equation, introduce you to your new best friend. M1V1 equals M2B2. This is how you solve any dilution problem. And so what we have are an initial molarity or concentration, and then we have an initial volume. And so this is like before we have the dilution. we have a certain amount of stuff and it has a certain concentration. And then there's after the dilution. So there's before and after. And so we call M2 our final concentration, and V2 is our final volume. Alright? So, we have these, two sides of the coin here. There's the before, there's after. And so, the way these problems work, I'm just going to let you in on the secret right now. I got to tell you 3 out of 4 and withhold 1. So maybe I tell you our initial concentration and our final concentration and volume. That means you have to solve for the missing piece. There's always one missing piece to solve for with 3 that are known. I did one time, maybe twice, but definitely once, I wrote an exam and I only gave 2. I gave like 2 molarities or something like that. It's like, find the final volume or whatever. So, the worst part was somehow I answered it in my key. I don't know what I had a number that I meant to type and didn't, but remembered it. And so students came up to me during the test. This was in class. This was back when we could have people in rooms, and they would be like, I think there's something missing. I can't do this problem. I'm like, no, it's all there. It's all there. It's fine. Because I did it because I knew something I didn't tell anyone else. And then only when I was grading the exams did I go like, oh no, I forgot to give them, V1 or whatever. So they couldn't actually do the problem. So free points for them that day. Students never did so well at dilution. So the other thing is, I got to tell you 3 out of 4 you solve for the missing piece. You're going to try to use this for everything. Those old molarity problems we did in the last video, you're going to be like, woohoo, alright, I know what to do. M1 V1 equals M2 V2. No. Only, it's the dilution equation for a reason. It's only when there's a dilution. So how do you know there's a dilution? I'm going to say something was diluted or a dilution was performed, or you're going to see the word dilute in there somewhere. I promise you that. Alright, so let's do an example of one of these problems. And I'll show you my process. Maybe you have a different idea how to do it. That's cool. This is what works for me. It's foolproof. I like to stick with it. So, let's say we have a 250.0 milliliter. We have 250.0 milliliters of 6.0 molar nitric acid. This was the second chemical to ever burn me. Everyone always remembers their second. Got some good stories about that one. This section's running long, though I don't know if I'll tell it. Is diluted. There's your clue to use the dilution equation to a final volume of 750 milliliters. Okay. What was the initial volume? Alright, so nitric acid. We're going to talk about it now. Turns your skin brown. Concentrated nitric acid will turn your skin brown, and it burns your skin off. It's a strong acid. It will let you know it was there, and then in addition to just making skin disappear, I mean like fast, unbelievably fast, it marks its territory by staining the remains brown. So it adds insult to injury. So I got just the tiniest dot. I don't have any scars from it. It's the tiniest dot. And you see like a drop of water on your skin or on a surface, and it's like this. My skin immediately went whew. It dissolved this. It just ate. It pitted it. It immediately mirrored that into a pit. It was unreal how fast it was. And then for weeks, I had this brown spot. And so that's how I learned. I was like, oh, nitric acid turns skin brown. My very first year teaching in graduate school, I'm not going to name names, but I had the worst student I'll ever have. You can try to take the mantle, but just by trying, you're already eliminated because this person did it effortlessly. And so this student was doing an experiment, and they were working with nitric acid, and it was concentrated, then they were diluting it for an experiment to do stuff later. And this student spilled it all over their hands. Now, they come over to me. I didn't see it happen. They come over to me. I'm running lab. I got like 12 students in there, so I can't watch everybody all the time. And the student goes, I just got that stuff on my hands. Pretty much exactly word for word what the student said to me. And I went, by stuff, do you mean the nitric acid? And they go, yeah, that's what it's called. Not a great start. And this was the honors lab, by the way. And so I go, they're like, what do I do? I'm like, you gotta wash your hands in cold water. You gotta run a cold water, not hot water. Hot water will make it react faster. Cold water for 5 minutes. And I'm thinking in my head, like, okay, they shook it and it started to dilute, and then they got it on their hands, thankfully, or they'd be screaming already with missing skin. So by diluting it, they bought themselves more time, but they still have to wash it off their hands or they're going to get chemical burns. And the student goes, oh, no, actually, I think I'll be all right. And I go, no, you need to wash your hands in cold water. You need to rinse them in cold water, or else you're going to get burns. And they're like, no, I don't really feel anything. I think I'll be fine. Keep in mind, like, I'm in charge of this person's safety, so their hands are going to get rinsed under cold water. It's got to happen. I mean, it's the ethical thing. No matter how I feel about somebody, I don't want them getting hurt. It's my job to make sure that safety protocol is followed. And then also, you know, it's just the smart thing to do. If you spill stuff in your hands, you rinse your hands. It's not rocket science for most people. And so the students was like, no. And so before I just physically take them to a sink, because I had it looked like I had 100 pounds on this student, I let them know, oh, well, nitric acid, I tried one last. I'm very proud of myself. This is pretty good. I was only, what was I was 23 at the time. I was just a young buck back then. And then literally this was, I guess it was the second quarter I was teaching. It was winter. I didn't have the student in the fall, but I had him for winter and spring. I took the diplomatic approach, and I said, oh, well, did you know that nitric acid was going to make your hand, it turns skin brown, and it's going to look like you have poop all over your hands. I literally said that to the student. And they went, whoa, and they're like, they got their hands in the sink, and they're like, how long do I rinse? And now I'm irritated. And so I go, oh, 10 minutes. Yeah, 10 minutes. You got to keep it under cold water for 10 minutes. I mean, I don't think they even kept it under for 5, but I at least got them to rinse their hands. And the best part was, I mean, I have so many stories about this student, but this is the only one I'm telling right now. And probably the only one I'll dare tell on the internet. They came up and thanked me after class that day. They were like, oh, thanks so much for letting me know that nitric acid would turn my hands brown. And I looked them down in the eye and I said, well, you know it would burn your skin off too, right? And they went, oh, yeah, I guess so, yeah. And they just ran out of the room. Which, for me, was as positive of an interaction as I could ask for. Because they were out of the room. But yeah, so, you never know when some little trivial piece of information that you learned the hard way can really come in helpful later to do something an easy way. So, now that I've wasted so much of your time, let's look at this problem. So here's what I do. I'm like, oh, diluted. Okay, that means I've got M1 V1 equals M2 V2. I'm just going to write out my equation, and I'm going to go, do I know M1? Well, there's my M1. This is what I started with, and I end with that volume. Okay, so it is 6.0 molar. Do I know V1? There it is. Do I know M2? Oh, I guess I should say what was the final concentration, huh? That would be good to know. No, I don't, so I'm going to put a question mark there. Do I know V2? Yeah, 750.0 milliliters. Okay, so I know I've now kind of broken it down. I've taken my word problem and I've broken it into something much more manageable. So I need to solve for this guy right here. I'm going to use algebra with letters because I like to show that I have a massive brain, and I get the following. And yes, this is correct. This is one way of doing it. Keeps my units intact. So M2 equals M1 times V1 over V2, and then I just plug my numbers in. This is where students tend to get a little dodgy from my approach, but I definitely recommend this first step. This is foolproof. You don't have to pay attention to what I ask for at the end. Like, look, I wrote the question wrong, and you know how I figured it out? Solving for my variables down here. It just doesn't let you down. All right, so M1, 6.0 molar. V1, 250 milliliter. I don't have to convert to liters, by the way. 750 milliliter. So I get 2.0 molar when I solve that bad boy. Got a little crowded there. I apologize. But 2.0 molar. I just take 6 times 250 divided by 750. So I'm essentially dividing by 3, multiplying by 1/3 to get 2.0 molar. 2 sig figs carries through. So that's what we do. And that will work for any of those variables being unknown. That approach is foolproof. But why does the dilution equation work? Look at that shorthand there. That is a chemist at work. So why does the dilution equation work? Well, remember, M1V1, if I take a molarity and I multiply by a volume, I get moles of solute. Well, guess what I have at the end? I have the same number of moles of solute. So I'm just hiding this number in the middle. So I can make these two directly equal to each other because I'm not changing how much solute there is. I'm only adding solvent. So moles solute does not change. So what happens is volume goes up, V2 is going to be larger than V1, but molarity is going to go down, and they're going to cancel each other out. They're going to multiply to the same number. That's what happens. And if that's not making sense, don't worry about it. Just know how to use your good old friend M1V1 equals M2V2. Just know how to use that to solve problems. How do you know? Dilution, dilute, diluted. Anything like that in the question, I'm not going to throw it in there as a red herring. That's going to tell you to use that equation. Alright, so that's it for molarity, or for dilutions, excuse me. So we got one more video in this section. We're going to talk about osmosis and osmotic pressure and osmolarity as well. We're going to the land of Oz in the next video, I guess. That's what we're going to do next. And that's the last one for the section. So the, I don't know what it is now, 5-6 hour long section will be done before you know it.